So, in the last video, we defined our angular momentum vector as the cross product between the position vector and the momentum vector. In quantum mechanics, the position and momentum vectors get upgraded to Hermitian operators. In one dimension, we already defined our momentum operator as p hat equals negative IH bar times the derivative with respect to x. In 3 dimensions, this generalizes naturally to p sub x, the x component of the momentum vector, is now negative IH bar times the partial with respect to x. P sub y equals negative IH bar times the partial with respect to y. And p sub z equals negative IH bar times the partial with respect to z. Notice that two arbitrarily p sub i's, p sub I and p sub j, commute with each other. So we're going to act it on a test function. We can pull out the factor of h bar. Well, since the order of differentiation of the function doesn't matter, we can just replace that with I and j, and now those are just the same thing and they're equal to 0. So two arbitrary components of the position, of the momentum operator commute, which means that we can have which means that they're compatible observables, which means that all 3 components of the momentum vector can have definite value. For angular momentum, we directly generalize this cross product here by replacing the p sub i's with their corresponding operators. So r crossed with p is now equal to I hat, j hat, k hat, x hat, y hat, z hat, negative IH bar, partial with x, z. Well, we can pull out this annoying factor of negative IH bar for each one. Now we're going to perform this determinant. So that's going to be y for the I. And then we'll multiply negative IH bar at the end. J hat. And k hat. Let's multiply each component by negative IH bar, and you're left with IH bar I hat. So it's going to be plus IH bar x j hat plus IH bar y k hat. Well, that's now the I component of the angular, or the X component of the angular momentum operator. And that would be the Y component. And that would be the Z component. So now we can have our angular momentum operators as IH bar and there's our angular momentum operators.